Everyone, welcome back to my channel. This video is designed to be step by step, super clear and easy for you to understand it 100%. So if you ever felt confused about convolutional neural layers, today that's end. So by end of this video, I'm quite sure that you will understand it 100%. No ambiguity, no guesses, no complex equations. So if that sounds good for you, please subscribe to my channel. It keeps me motivated and simplify complex topics just for you. So and don't forget to check out the playlist packed with the easy to follow videos on machine learning and also deep learning. So all right, let's dive into it. So have you asked yourself how computer, let's say how computer or maybe the program detect, recognize, let's say a cat or dog? So this is magic behind the convolutional neural network. And today I will go dive into this uh, convolutional neural network, understand the convolutional itself, and what is the filters, what is the stride, padding, how the convolutional is working, and what is the feature map, how the feature map is affected by multiple filters, what is the output size of the convolutional network, how to calculate the parameters of this convolutional network. And this is, let's see, preparing to upcoming layers like pooling layers, ReLU, and of course table learning CNN stack, because you have many stacked layered layers. So at the heart of every CNN lies a filter. So a filter, it's a small matrix that slides across the image like a scanner, searching for the feature. Think of it as a detective looking for a patterns, edges, texture, curve. Whether it's 3 by 3 or 4 by 5, each filter has a mission. So as you can see here, for instance, it might be 3 by 3 or might be 5 by 5. And the strides, this is the scanning process is called convolution, and it works with precision. So slide the filter left, right, down, step by step. So this step size, it's called the stride. And as you can see, for instance, here this filter is moved one move, and if you see this stride two, is the filter is moved two moves. So as a try to, so we try to, let's see, to make it step things up, speeding it to make a speed, and this is the cost of some details. So if you see, for instance, if the stride 2 is moving up, it means making the steps, but be quiet that we will miss some features. And what is the padding? What about, for instance, if you have some edges in this filter, in this boundaries here? So this will be, let's see, without paddings it will be removed, but sometimes we need it. It's more important, so what that's why we need some paddings. And by adding zeros around the image, we preserve the original size. So the output size of the image after convolution, after adding this padding, it will be the same size as the input image. We will see it in a minute. So because sometimes the border hold, let's say, a keys. So this, for instance, the borders of the image. Now let's zoom in. So here's, for instance, I have multiple filters. As you can see, one and two. So please don't be confused that I have one, two, three, four, five, six. No, this is one filter. This is the first filter, and this is the second filter. And because I have three channels, for each channel I will have one, let's say, sub filter, and that's and each filter will be responsible for detecting vertical lines, circles, and maybe the after the coming, I mean, deeply in the coming layers, it will detect the eyes or human or the whole object. But please don't be confused. These parameters, these filters, it will be updated during the training, so it's not fixed on all the neural network. And let's see how to calculate the output, the output shape. For instance, I have this image here. Let's see, just go to this, and I have the image. The image size is, for instance, 5 by 5. Now, how to see what is the output size of this? So output size, it will be the width of the input. Yeah, by the way, this could be also duplicated 2 times, one for width and one for height. Let me just make it clear. Width, width and height of the output image, and height. And this, for instance, will be width, and this will be height, of course, of the image. Sometimes you need not the square image. Sometimes you need you have image 300 by 500, for instance, or 500 by 700, or 500 by 20. This is different. So you need to calculate the. You don't need to make, let's say, your image as a square, but some, of course, some algorithms we will go in the coming videos. It's need to have a square image. That's why we need to resize. But as a general idea, this is not required to have it. The width and height is equally. So sometimes you might have different width and different height. This is, of course, fine. Now this is the width, calculate the width, and this is to calculate the height. And the width and height, for instance, this is the width, for instance, the width, and this is the height, the value of the height. Here, kernel size is the key, and 2 multiplied by padding, how many padding we need to add, and also divided by the stride, and then we will see +1. Let's just have an example here. So assume that I have the input size is 32, and the kernel is 3, padding is 1, stride is 1, and the output. And what is the output size? This should be removed because we need to find this. And you can see here, I will just apply this. Let's assume this the image size is 32 by 32. Now the kernel size is 3. Now if we see 32, 32 minus 3, which is the kernel, plus 2 multiplied by 1, which is the padding is 1, divided by 1 is the stride. It will be 32. This is when we add a padding. It will be 32. If we remove the padding, this will be, for instance, 0. This 2 times 1, it will be 0. And the output will be 30. And this is how to calculate, for instance, this. I have 5 by 5 image, 5 by 5, and the filter size is 3 by 3, and the output will be, of course, 3 using this formula here. So now how the convolution is working. So let's see, I have, after giving this information here, for instance, the stride, the filter, and padding, and etc. So let's see, this is our image here. And I have this filter, right? Okay. Now I will take, I mean, our filter will scan. We will take, let's say, 3 by 3 from this image and multiply it by the filter. And you can see, for instance, I will, for instance, for this 3 by 3 here, I will try to multiply 7 by 1 plus 2 by multiply times 0, 3 times minus 1 plus 4 times 1 plus 5 times 0, and etc. This will calculate the feature map, called the feature map. And the size of the feature map will be 3 by 3. Now assume that we have many multiple filters. What will be the output? So this is our image 5 by 5, and here our filters. I have added 3 filters. So now for each filter I will get feature map. For each filter I will get a separately feature map. So please don't be confused. I will explain the image with many channels in the next session. So as I said, for each feature, it will be one. For each filter, it will be one feature map. And here I have 3 features, so I will get 3 feature maps. Now assume this is our image, 3 by 3. No, 5 by 5 by 3. I mean, this is 3 channels. Now, and here I have filters 3 by 3 by 3. This is only one filter. So please don't be confused. In this previous example here, I have three filters, 3 by 3 by 3. And in this one here, I have only one filter because the input, the channel number of channels in the input layers have to be identical to the number of filters. So if you see here, I have 5 by 5 by 3, right? And this here, 3 by 3 by 3. So if I remove this and removing this, I will have only one filter. So it's only one filter, one filter for kernel for each channel. And the output, I will do the calculation like what I have done here for each filter, let's see, for each subfilter, and adding the result, sum up of the result in this one here. For instance, I will start with 0. Let's see, I have here 3 by 3. Where is the, let's see the shape. I will I will add here 3 by 3. Let's see. Okay. Now this is the 3 by 3. I will multiply this, and for this I will have only one value, as we have done it here. So for instance, this filter, it will take the 3 by 3, the first 3 by 3, multiply it, and I will get only one value. The same for this. I will get one value for this, and the second filter, it will multiply with this, the green one, I will get one value, and for the third one, I will multiply with this, I will get one value. Sum all of these ups values, and it will be, let's say, 5. This is, maybe the calculation is wrong here, but this is the concept. Now see here, I have many filters. Why I have many filters here? It's, as you can see, this the size, the number of filters is 32. As I said, the number of channels here is 3, and the number of channels, this is the third one, this is 3. So everyone here, for instance, this is one filter, and the second filter, it will be here, and then this is the last filter, which is 32, number 32. Now for each filter, I will try to apply the same mechanism for here, and the output filter, I mean the output feature map, it will be, let's see, 3 by 3, sorry, by 32. So this will be the feature map output. Let me just see it again. Maybe it's, so here I have 3 by 3, 5 by 5 by 3. Now each filter in this, it has to be, let's see, n by n by 3. And here, for instance, I have 3 by 3 by 3. Now, how many filters I would like to apply for this image? It's 32 filters. And for each filter, I will get a feature map by the calculating of the output feature map with this formula here. With this formula, I will have, for each one, I will have the same, of course, output. Not not the output, the size of the feature map. Of course, the output should be different. And the number of filters, it will be 30. The number of channels, it will be 32. And now how to calculate the parameters in the convolutional neural network. So as you can see, for instance, in this image here, I have this image, and I have this filter here. How many parameters? As I said in the beginning, this is parameters. It will be changed, update, and during the training. So it's not fixed. This will be changed over time based on the cost function or loss function. Now, what I was thinking, I was seeing, yeah, how many parameters here? As you can see, 1, 2, 3, 4, 3 by 3, it's 9 parameters. 9 parameters plus bias, 1 bias. For each filter, I have 1 bias. Now, let's see here. How many parameters I have here? It's 3 by 3 by 3. It's 27 plus 1 because it's only one parameter. And here it's different. So I have here three feature uh, filters. It will be 3 by 3 by 3 plus the bias is for each one is 1. So I have 3 biases here. And let's go back to this number of parameters. Assume that I have the image is 3 by the input image is 3 channels and 3 channels. I have let's just check. So you have the no, it's the image. It should be let's say 3 by 32 by 32. But it's not let's see matter. The image size it's not affecting in the parameter size, only the filter. So here's the width of the filter. Height of the filter is let's see 3 by 3. Yes, you see 3 by 3. So I will see 3 times 3 times how many number of features. Let's say the output features number of filters is 32. It will be 3 times 3 times 32. Then multiplied by number of filters. This is number of, no, sorry, I have a mistake here. Yeah, let's start how to calculate the parameters from scratch. So with using this formula here, I have the filter width of the filter and height of the filter and width of the filter. Multiply the channels, number of channels of this filter, and times, of course, number of filters plus the bias. And the bias, it will be number of plus n, number of course, this will be n. Let's say n. And let's apply this. I will have how many, what is the filter height? It's, as you can see, 3 by 3. It will be 3 times 3 and times number of channels. It will be 3, of course. This will be number of channels. This one here. And plus how many, what is the number of filters? See, as I said, number of filters is 32. And plus number of not number of yeah, of course, number of filters 32, of course. Now as you can see here, 3, this is the filter width, filter height, number of channels in the input in the input image. Now how many parameters, how many filters I have? 32 plus the bias number of filters. It will be almost 900 parameters. So if you go back to my previous video and see how many parameters we have for this, I think for this image 32 by 32, or you will get hundreds of thousands of parameters for the connected layers or dense layer. But using this CNN, it will try to reduce the number of parameters, also keep the speciality, and also I have this filter. You can see the same filter will be used for the whole image, but only with this specific region. You can see here. And let's see, I have show you the simple example of Python. See, I have the batch size, the image size is 3, and the image size itself is 3 by 3, and they have color images. Let's see, it's color image here. But in a PyTorch, it's starting with the channel, and maybe the Keras it will try to say 32 by 32 by 3. It's different, so it's only to show it. This is the number of channels. Let's see red, green, blue, and this is the size of each of each channel. And with the CNN, with the PyTorch, you can import this. You can import neural network and dot conf 2D, and number of channels is 3. You can see this is number of channels 3. Output channels I need 32 parameters. Let's see other parameters, and number of parameters this one here. And kernel size, let's say the filter size is 3 by 3, but we need only the first parameter, because the here in the conf it's saying the parameter is a square, 3 by 3 or 5 by 5, or, and the stride is 1 and the padding is 0. So what do you think about this? How many parameters do we have here? The shape. I mean, not the parameters. The shape of this output. It will be 32. Let's see, ignore this one here. For instance, ignore this. And if we apply the formula that we need to calculate the parameters, to calculate the feature map, you can use this one here. So it will be, let's say, yes, here, the width of the image is, let's say, 32 minus 3 plus 2 times 0, it will be 0, divided by the stride is 1 plus 1. So this will be 30. And it will be 30 by 30. Now, how many parameters we have? Output channels is it's 32. 32 parameters. Yeah. So I think that's it for today, and I'm hopefully you all also get everything in this tutorial. And if you have any question, please drop it down in the comment below. I will answer it, of course. And happy learning. Thanks for watching. Bye bye.